but it just lumps all of the memorize your calculator first 20 perfect squares. So a perfect square is like 1 times 1, 2 times 2, 3 times 3, and so on. So find the first 20. Here they are. Ideally, you should have memorized at least up through 225. So if you see any of these first 15 numbers, you should know if that's a perfect square or not, and you should know what the square root is. So if I say, what's the square root of 196, you should know that it's 14. Now these other ones, if you got up to 20, that would be nice, but at least 15 will help you out a lot. So when we have a square root, we could have a perfect square. If I say, what's the square root of 81, you're going to tell me 9. We're going to see a lot of non-perfect squares. If you were to type that into the calculator, like if I said the square root of 110, that's somewhere between these two. So it's going to be 10 point something. All right, it's between 10 and 11. So 110 somewhere. But I don't want a decimal. I want you to have a simplified radical, which you have seen early in the year when we did those ACT things each day. Now, either way, if there's a number outside of the radical, like in number 3, you multiply first thing I'm starting with is actually a fraction. When I have the square root of a fraction, that's the same thing as having the square root of 4 over the square root of 9. You can rewrite it that way. And what is the square root of 4? And the square root of 9? 3. So the square root of 4/9 is 2/3. We have a fraction again. That's the same thing as the square root of 1 over the square root of 81. Which would be what? 1 over 9. Okay. Number 3 is 2 times the square root of 144. What's the square root of 144? 12. So 2 times 12 is 24. So those are the easy ones. When I get to number 4, is 32 on my list of perfect squares? No. So when I have a non-perfect square, we're going to break it into 2 radicals that are technically being multiplied together. So we want 2 numbers that multiply to be 32, and one of those numbers has to be a perfect square. Specifically, we want the largest perfect square. So what is the biggest perfect square that goes into 32? 16. Because 16 times 2 is 32. So this needs to be the largest perfect square that divides evenly. Now, do we know what the square root of 16 is? 4. And then the other one, the square root of 2, we can't do anything else with that. So 4 square root of 2 is completely simplified. Now, if you would have picked, let's say 4. 4 is a perfect square that goes into 32, but it's not the biggest. What would have happened is that when you got your answer, what was left under the radical could still be divided by a perfect square again. So you'd have to do that step again. And that's fine. You could keep doing it, but it's more work that way. Number 5, square root of 12. What's the largest perfect square that goes into 12? 4. 6 is not a perfect square. 4 is the largest perfect square. 4 times 3. It's actually the only perfect square that goes evenly into 12. And what is the square root of 4? 2. And then bring down the square root of 3. Number 6 is the square root of 112. Now this one might be a little harder. You may not know this one right off the bat. So here's what I suggest. Take your calculator, and we're going to take 112 and we're going to divide it by our perfect squares to see which ones go into 112. And since we want the biggest one, it's better to work with the bigger numbers and then work your way backwards. Now obviously you want to divide by numbers that are smaller than 112. Okay. Is there any point in dividing by 100? No. It's not going to go evenly. So I might start with 81. Nope, not a whole number. 112 divided by 64. Not a whole number. 49. Nope. 36. Nope. Okay, I know 25 isn't, so I'm just not going to waste my time. It's actually 16. So 16 is the largest perfect square that goes into 112. It's 16 times 7. And what is the square root of 16? 4. Bring down the square root of 7. Let's do number 7. And the reason that I suggested that you know your perfect squares is when you're doing this, you don't want to have to pull out a list every time or write out your own list. That takes a lot of time. So 245, I'll probably start with 81. I know any numbers bigger than that really aren't going to go in there. You might want to try 121, but 245 divided by 81. 245 divided by 64. Found it. $49 times 5 gives me 245. And what is the square root of 49? 7. Bring down the square root of 5. Number 8 actually has a 5 in front. So what that means is that I have 5 times my 2 radicals. So whatever whole number I get at the end, I have to multiply that by 5. But we still break down the 72 into 2 radicals. So what is the largest perfect square that goes into 72? 36 is the largest. There are some numbers that you might see a lot. 72 tends to come up a lot. And what is the square root of 36? 6. So it's really 5 times 6 square root of 2. And you can multiply the 5 and the 6 to get 30 square root of 2. Good. Try number 9 on your own. The largest perfect square that goes into 45 is 9. So we have 3 times the square root of 9 times the square root of 5, which is really 3 times 3, or 9 square root of 5. So let's turn the page. And now we're going to put that into play with our unit. So solving quadratics by square roots. This is kind of like maybe you could call it a shortcut method, but whenever I have a quadratic equation that is missing the bx. So here's my standard form. If it's missing that middle term, there's no plain x. There's an x squared, there's a number, just no x. You can use this method, and it tends to be quicker than factoring would be. Kind of basically we're solving it like a 2-step equation that you would do in Algebra 1. So our goal is to get the x squared by itself, and then we take the square root. So let's look at number 1. I have x squared minus 64 equals 0. My goal is to get the x squared by itself. So what do I do to solve? Add 64 to both sides. Is my x squared by itself? Yep. So step 2 says to take the square root. Taking the square root gets rid of the squared. And what is the square root? Quadratics. I'm going to show you a graph. Oops. Where does it look like it crosses at? This is positive 8. That's negative 8. When we do quadratics, you have to include the positive and the negative. Because if you just put 8, you're telling me that it only has one x-intercept at 8. You could also write it like this, plus or minus 8. That means positive 8 and negative 8. So that's one thing you have to remember to do. It was up there in step 3. Very important. So let's do number 2. What's my first step?
Isolate x.
How do I do that? Subtract 8 first. I get 7x squared equals 7. Then what? Not yet. Divide by 7 first. We get x squared equals 1. And now what?
Now I take the square root.
Now I take the square root. what do I get for my x-intercepts?
1 and negative
1 and negative 1. Yep, you'll always have a, when you're solving with the root method, you have to put the plus or minus. Or you could just list positive 1 and negative 1 separate. So you have 2 x-intercepts. Number 3. What's first? Subtract 5. Good. 81x squared equals 16. Then what? Divide by 81. Now if you type that in the calculator, you're going to get a decimal. Just leave it as a fraction. X squared equals 16 over 81. And then you can take the square root like we did with the fractions on the first page. So it's x equals plus or minus what? 4 over 9. Let's look at number 4. Subtract 1. We get 8x squared equals 16. Then you divide by 8 to get x squared equals 2. Then what? Square root. Is 2 a perfect square? No. Are there any perfect squares that you could divide into 2? No, besides 1, but that's not going to do anything. So my final answer is just plus or minus square root of 2. It's possible that you will get a number here that can't be broken down. Let's do number 5. Add 9 to both sides. And that gives us 2x squared equals 64. Then you divide by 2. X squared equals 32. And then I take the square root. Can I break 32 down? Yeah. What's the largest perfect square that goes into 32? 16. 16 times 2. So x equals plus or minus, what's the square root of 16? 4. Bring down the square root of 2. If you want to check, you can just plug that back in for x. So you could do 2 times 4 square root of 2 squared minus 9, and you get 55. Try number 6 on your own. Here's the answer for number 6. Plus or minus 2 radical 15. Are there any questions?